Greetings, fellow mathematicians. Let's take a look at a quick problem on applying the direct comparison test. The infinite series we're given involves the term 1 divided by 2 to the nth plus 1. And in order to apply the direct comparison test, you need to have an idea of whether you should look for a bigger infinite series term or a smaller infinite series term. To determine that, we're going to go through a large n estimation. So let's go ahead and call this a sub n. And we're going to see what happens to this as n becomes very large. So we're going to think of n becoming really big. The numerator is just going to stay as 1 since there's no n's in the numerator. And when n becomes even moderately sized, 2 to a power, that's going to become much bigger than 1 very quickly. So as n continues to grow, that plus 1 is insignificant. So in other words, the denominator behaves like 2 to the nth power. Now you might not recognize this term in that form, but let me go ahead and apply some basic exponent rules. I can rewrite this as 1/2 to the nth power. And we're going to recognize this, a number to an nth power, that is a geometric series. And here, the value for the ratio r is 1/2. And since that is less than 1, that geometric series is convergent. Now this doesn't prove anything, make sure you realize that, but this at least gives us some guidance. Our infinite series behaves like a convergent infinite series. So this should tell us for the direct comparison test, we want to look for a bigger infinite series that we know for sure converges. So all this says is this is going to guide us to looking for a bigger term. All right, so let's go back to our infinite series term, a sub n. And again, because we suspect that our infinite series is convergent, we're going to look for a bigger infinite series that we know for sure converges. Now, since we're working with a fraction, we can get a bigger fraction by making this denominator smaller. And I can make it smaller by getting rid of the plus 1. So that is certainly true. This is less than 1 over 2 to the n, which we can rewrite as 1/2 to the n. And this is a convergent geometric series. And we just write this up, since the infinite series with that term, 1/2 to the n, is convergent. In other words, the bigger term gives you an infinite series that is convergent. If the bigger is convergent, the smaller is going to be convergent. And we just write the conclusion here that our infinite series of 1 over 2 to the n plus 1 is convergent. And this is, again, a standard problem in a Calc 2 course. Make sure you're comfortable with the steps, the large n estimation that guides you towards looking for a bigger infinite series, since the large n term behaves like a convergent infinite series. And then you just look for it, use your usual tricks. With fractions, you can get a bigger fraction by making the denominator smaller, and it should fall into place rather quickly. Hope you enjoyed the short video. Like and subscribe.